We are going to see the experiment characterization of WDM, MUX and DMUX. The objective is to determine the insertion loss and loss uniformity of each channel of WDM MUX. Next is to determine the optical crosstalk in adjacent channels of WDM DMUX for various wavelengths. For this experiment to be conducted, the components used are C-band lasers. So these are the C-band laser source, 4 laser points, 4 channel WDM MUX, this is the MUX unit, and 4 channel WDM DMUX, and this is the 4 channel WDM DMUX unit, and the corresponding photo detectors, and these 4 are the corresponding photo detectors for the 4 laser sources. Now we'll get into the experiment. Select characterization of WDM MUX and DMUX, and this is the page appears once you have selected. Now consider 1550 nanometer, and the frequency, duty cycle, laser power all need to be set in default 50 kilohertz, 50% for duty cycle and laser power respectively. Now connect the laser source 1550 nanometer directly to this MUX point of 1550 nanometer, and the MUX out will be taken to the PD. And click on the start button from the display. We will get the output power as well as the waveform. So once you have received the waveform, remove it and connect it to the power meter, and we receive 204.1 for 1150 nanometer, and this is the output power. And prior to this, we have to measure the input power by directly connecting the source optical cable to the power meter. So here it observes 240.3. So this will be considered as the input power, and from the MUX out, the power will be considered as the output power. And you have to replace the source cable to the 1550 nanometer, and this cable to the power. And with the help of this, you can note down 1 minute. So this is the insertion loss of MUX. So you have to note down the input power for all these 4 sources and the output optical power for all these 4 sources. With the help of this insertion loss expression, we can calculate it correspondingly. Now we'll see the crosstalk, and this 1110, all the 4 sources, you have to consider P1, P2, P3 and P4. This is the crosstalk formula. You have to calculate the crosstalk for all the channels. Now we'll see the DMUX. Select this 1550 nanometer with all the default settings. So this input power we already measured, and the source will be connected to the MUX of 1550 nanometer, and the mux output will be connected to the input of demultiplexer, and the output from 1550 nanometer from demux block will be connected to the optical power, and switch on the start button will receive some powers here. 172.8, and with this we can get the demux output. So we can calculate the characterization of WDM, mux and demux. We can check the power. So proper signal over here. Click on the start button. So you will receive the demux also. So thus we have obtained the results out from this. The insertion loss of each WDM mux channel and the loss uniformity is determined. The optical crosstalk involved in WDM mux is also measured here. Thank you.